Welcome. In this session, we'll learn how much energy is stored in the capacitor after the capacitor charges for some time. All right, let's start. So in the previous session, we learned when we connect an RC circuit, when we connect an RC circuit to a battery through a switch, Vs, the capacitor voltage when we connected the switch at equal to 0 looks like this. Vs1 minus e to the power t by tau, and tau is simply equal to R. See, and it has the units of time. All right, so this is the voltage across the capacitor at any instant of time. All right, now let's assume at any instant of t, means after connecting the switch for time equal to t seconds, the voltage across the capacitor at t equal to is V0. Means after connecting this switch to this battery to this RC circuit for t seconds or t minutes, the voltage acquired by the capacitor is V. All right. Now let's observe now how much is the energy stored. Right. Now we know the instantaneous power we can obtain by like this. We say P is I times V, right? Where we end the instantaneous values, but we can write I in terms of V. So that will be C dV by dt times V. So we can write it as CV dV by dt. So what's the relationship between energy and power? We know energy is equal to integration of power, right? So if we are connecting this switch for time equal to t, so the limits will change from 0 to t. So substituting the values of P, so it will be CV dV by dt times dt and dt, as you can see, will cancel. From this, it will be from 0 to t, CV dV. C we can take outside, so it will be. Now you can see the integration is varying with respect to V, but our limits are with respect to time. So let's change this. So how much will be the value of this? At V is equal to 0, the voltage stored in the capacitor is 0. At V, t is equal to time, when time reaches t, so the voltage across the capacitor is V0 that we assumed. Now integrating this, we'll get E is equal to C V0 square by 2, 0 to V0. So that means after substituting this limits, we'll get the value of this energy will be 1/2 of CV square. So the voltage stored in the, energy stored in this capacitor after t is equal to time is equal to t seconds reaches to this 1/2 of CV square, where V0 is the voltage stored in the capacitor at time equal to t. Okay, that's important. So this much is the voltage stored in the this capacitor after we connect it to a source like this. All right. Okay, let me end this session here.